right, so like I said, your book goes into much more detail as far as the error analysis between the trapezoid and the midpoint rules. I included a little bit of it here, but the gist of it is that in general, the trapezoid error has the opposite sign and about twice the magnitude as the midpoint error. Okay, and so that's where Simpsons rule comes from, is it's essentially a weighted average of the midpoint and the trapezoid rules. So so we're taking 2 times the midpoint rule and the midpoint rule estimation and adding 1 times the trapezoid estimation and dividing by 3. So it's a weighted average, okay? And because the midpoint rule tends to be a little bit more accurate, so we're weighting the midpoint rule estimation a little more heavily. Okay, so let's see this in action and go on to example 4. Okay, so I'm going to leave Simpsons rule there so we can refer back to it. And here we're asked to calculate Simpsons rule for this function g of x equals the square root of 1 square root of 1 plus x cubed. All right, so what do we need to do? Well, essentially we need to do everything, because in order to get the trapezoid rule, we have to average the right and left estimates. And so we have to calculate the left estimate, the right estimate, and then average the two to get the trapezoid rule estimate. And then we can calculate the midpoint rule. And then once we have all of that done, then we can calculate Simpsons rule. All right, so let's just dive in. We got a lot of work to do. So the first we're going to do is just calculate the left rule, right? And we're going to use 3 subintervals. Okay, so we're breaking 1 to 4 into 3 subintervals. So I can show that here. I'm going from 1 to 4, right? So the difference is 3. So 3 subintervals just means that we have a delta x of 1, right? Delta x equals 1. That's the width of our subintervals, because we're trying to find this whole area right here. Okay, so we're going to break it up into these 3 subintervals: 1 to 2, 2 to 3, and 3 to 4. All right, so to calculate the left hand estimate, we're going to take f of 1 times the delta x, which is 1, plus f of 2 times 1 plus f of 3 times 1. So we're just going to put 1, 2, and 3 into this g of x formula. So what I end up with, if I plug in 1, I get the square root of 2 and times 1. And then if I plug in 2, I get the square root of 1 plus 8, which is 9, square root of 9, plus the square root of 3 cubed is 27, plus 1 is 28. Okay, and I add that all up and I can get a decimal approximation of 9.705716. Okay, so there's the left. Now let's do the right. R-I-G-H-T. Okay, and so now we're just going to take those right-hand data points. So we need f of 2 times the interval width, which is 1. And then we have f of 3 times 1 plus f of 4 times 1. Okay, so we're going to just evaluate the function at 1, or sorry, not at 1. We're going to do the right-hand points. So we're going to evaluate the function at 2, 3, and 4 now. And I'm going to get the square root of 9 plus the square root of 28 plus the square root of 65. And that gives me 16.353760. All right, so now once we have the left and the right, we can easily calculate the trapezoid rule. So trap 3 is just the average of the two, the left and the right. So I'm going to average 9.705716 plus 16.353760 and divide that by 2. And what I end up with is 13.029738. Okay. All right, now, so that gives us a trapezoid. We need that. That's this part of Simpsons rule. And now we need the midpoint rule. So I'm going to do mid for 3 intervals. Okay. So now I have to take the midpoint. So I'm going to have f at 1.5. Again, my interval width is 1. And then f of 2.5 times 1 plus f of 3.5 times 1. Okay. Now I'm just going to plug in, I just used my calculator and just plugged in all these values but when I do that, I ended up with 12.792847. Okay. So now I have a mid and the trap, and then I'm going to apply Simpsons rule. So simp 3 is just going to be 2 times the midpoint rule, which is 12.792847 plus trap. Okay, so that's 13.029738. And I'm going to divide that by 3. Okay. And what I end up with is 12.871811. All right. That's a lot of work for one number, but that's my final answer is 12.871811. Okay, so that's the Simpsons rule approximation of that integral. All right, so all that's left is our discussion questions. So I will let you try those problems, and we'll see you in class.